Hello everyone. Today I am going to explain you descent in symmetry with substitution in molecule. Right. When we are substituting an atom or an element or a group in a molecule, its symmetry point group will get decreases. Okay. This is due to the substitution on molecule. It changes some. It makes that the some of the symmetry elements to be disappear, some of the element to be absent, right? So thus criteria will known as descent in symmetry, right? So when we look into a water molecule, for example, if we are going with a water molecule, we know that it is a angular shaped molecule, right? And its point group is C2E. It all discussed in previous classes, right? If you don't know, right, go through the previous classes. It is an C2E point group. When the hydrogen is substituted with some X atom, right, it certainly gets such moiety, right? So perchloric acid, for example of perchloric acid, right? So here the C2V point group, when it for the water, it will have E plus C2 plus 2 sigma V's, right? Where when we are substituting one of the hydrogen with one of the hydrogen with some X element, such as chlorine, when we are substituting, so this is the moiety it generates. Where here when we want to make a C2 rotational axis as such in the water, right, this is what the C2 rotational axis, it is not present here, it will become absent, right? While we do certain axis and doing 180 degrees of rotation, may replaces hydrogen by x by hydrogen, which is never be an equivalent configuration. So it means that the C2 is absent now, right? Same to that, the plane, it has certainly it has this plane and a molecular plane, both it has as a vertical plane of symmetry. But in here the plane what we have, which is bisecting by the only oxygen, and in between of x and h, when we are in between of x and h when we are applying plane, thus the plane will also be never generate an equivalent configuration, which means thus the vertical plane which is seen in the water molecule also absent in this particular moiety. So it has remained only one element, that is the molecular plane, as the even if we are substituting h by x, it is in planar moiety only, v shaped planar moiety only. So when we are applying a plane passing through all the atom, it will give you a equivalent configuration. So this moiety, this particular structure will have E identity will be there, and a plane of symmetry it will there. So which means the point group of certain this, here it is only CS. So here having 4 symmetry elements, upon substituting H by X, it became 2 element CS point group, so like this the substitution may decreases as a point group, or the symmetry elements absent will takes place upon the substitution. This certain criteria will be known as descent in symmetry. We can go with multiple examples. Even we can take ammonia, right? Ammonia, you know what is the point group of ammonia? It will be, it is a C3V point group element, C3V point group molecule, where it will be have 6 elements such as E plus 2 C3 plus 3 sigma V's, right? Where here substitution of H with some X or some A, right? So there the A substitution will make the molecule to be right, where here when we go, the principal axis C3 principal axis will absent here. The substitution of hydrogen by 120 degrees on ammonia will give you a 2 C3 rotational axis, but here thus operation may not be given an equivalent configuration, so it will be absent, right? It may have identity, but the rotational axes are absent, right? So even if we are applying a plane of symmetry, the plane, this particular plane only will have a plane of symmetry, other than this, right, it may not have. Here in the ammonia, with all nitrogen to hydrogen bond, when we make a plane, when we bisect the molecule into equal halves, it will give you a 3 vertical planes. But where here, right, a plane passing through nitrogen A bond, when we apply, thus only will reflect the similar hydrogens and give you a equivalent configuration, and it will be a plane of symmetry, right? Other than that, there will not be any. If you are applying like this with nitrogen hydrogen bond, it may substitute hydrogen to A, which will not be which will not lead to a equivalent configuration, so they may all absent. So it have only 2 elements, and thus again it is a CS point group only. So again, from the 6 elements of C3V point group to ammonia, it decreases its element to 2 elements only CS point group, right? Certain such change, right, will happens with the substitution on molecule, right? Certainly here again we can also go for a moiety of chiral carbon. Let us go with an methane, right? A methane tetrahedral methyl molecule, right, where we know that tetrahedral moiety is a special symmetry element, where symmetry point group, where it will be have tetrahedral point group, and it are 48 elements, it is, right? It will have 48 elements. Upon substitution of one of hydrogen by some X element, some X or A, some A with, when we are substituting, what happens is this is H1 when we are substituting with A, H1 is substituting with A, what happens is it may result a such molecule, right? This may be equivalent of chloroform, chloromethane, right? Such molecule it is. When A is chlorine, it will become a chloromethane, right? So where here, from here to here, H1 substituted chlorine, it will be chloromethane, and its point group is C3V. Its point group will become C3V, while we are doing an axis and carbon to A axis and doing 120 degrees of rotation, will have C3 rotational axis, and there will be planes of symmetry through carbon A hydrogen and carbon A this hydrogen, carbon A this hydrogen, right? If you make a plane, thus the results of 3 vertical planes, so it will become 6 element moiety, it will become, right? 48 to sudden decrease of 6 elements only it will appears in this particular chloromethane, right? So when again more substitution, when we do another hydrogen substitution by A, it will result of CaAH2, where it would be the molecule like be dichloromethane, right? In this the moiety, it has a rotational axis which is passing through only carbon and doing 180 degrees of rotation. It may have substitution of AA and HH. It will be results of equivalent configuration. It means there is an C2 rotational axis, and it will have them 2 vertical planes in here, right, passing through 2 AA atoms and carbon. When we are applying a plane, it will have reflection of hydrogens, that is the one plane, and a plane passing through 2 hydrogens and carbon in between of AA, it results in reflection of AA, and that is also an equivalent configuration, and such 2 vertical planes are possible. It will become a C2V point group. It will become a C2V point group. right? Otherwise, right, when we are making substitution, this particular substitution by B, H by B, when we are substituting, right, it will result of A, B, H, H. Here in this criteria, only there will be plane of symmetry. No more rotational axis possible here, right? The plane passing through carbon AB, when we are going, it will be in between of two hydrogens, and reflection of hydrogens will give you a plane of symmetry. So it will be CS point group only, right? Two elements CS point group only, right? Thus decrease also it is happening, right? So further, when we are making more substitution, again hydrogen substitution by C, carbon A, B, C, see here the CC may get reflected. Here we do with the P, certainly when we take P, right? So here NH hydrogen, right? There in this moiety, carbon has all different substitution A, B, P, H, right? So all different substitution makes that the moiety is an chiral carbon. So in this case, the chiral carbon will have the point group of C1 point group, where it will have only identity, only one element, that is identity it has, right? So like this, the substitution in molecule, right, substitution of atom or group or element in the moiety may decreases the point group, right? May decreases the point group, or may absence the symmetry elements, right? May disappear some of the symmetry elements, will decreases the point group, that means a descent in symmetry, right? So in some time we can also observe the ascent in symmetry. Ascent in symmetry with substitution, right? So here we have to take reverse, right? So considering a chiral carbon center, right, like bromo, chloro, fluoro, methane, bromo, chloro, fluoro, methane, when we consider here, when we are substituting fluorine by chlorine, what happens is, the same moiety substitution, what happens, the chlorine and hydrogen, this can be written as bromine, hydrogen, chlorine and chlorine, right? So here in the case, as it is a chiral center, it will have the C1 point group. Point group is C1 point group. Only one identity element only it will possess. Where upon substitution of fluorine by chlorine, right? Chlorine by fluorine, it will result of dichloro bromodichloromethane, right? Where this here what happens is, there is a plane possibility it has. While we do apply plane passing through bromine, hydrogen and carbon, where it will be in between of two chlorines, results a equivalent configuration. So it has identity. In inclusion of that, it also gets the plane of symmetry, which means the point group will become CS, and its number of elements are 2, right? Here one number of element, chiral carbon, upon substitution it results a new element, it elevated a one of the new symmetry element, thus enhancement of new element, thus gaining a one of the symmetry element in the moiety upon substitution, known as ascent in symmetry, getting enhancement of point group, right? Generating new symmetry element in the moiety upon substitution will be known as ascent in symmetry, where the best example is chiral carbon. When we are substituting one of the different element by similar atom, it results a enhancement of point group, where again further enhancement, right? When bromine is replaced by another chlorine, will give you a carbon, chlorine, 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 right? This is a chloroform. It is also of chloroform. Thus chloroform will have C3V point group, will get a C3V point group. So here there are 6 elements it will generate. There will be C3 to E plus, there will be 2 C3s plus 3 sigma V's it will have, right? So having 2 to 6 elements, they are enhancement, right? So this is also an ascent in symmetry. And further, when we are substituting hydrogen by another chlorine, it results of tetrachloromethane. This will be a tetrahedral point group. It will be high jump of 6 element to 48 elements point group, right? It will be tetrahedral point group and it will possess a 48 elements. Like this, enhancement of symmetry elements in the molecule with the substitution will be known as ascending symmetry, right? So like this, ascending descending symmetry we can discuss, right? So here I stop. It may help you in the study of ascent descent in the symmetry point group, right? Thank you.